Hi there, my name is Juan Andrade. I am a associate professor of global nutrition in the Food Science and Human Nutrition Department at the University of Florida. My long-term goal is to develop and evaluate sustainable strategies and technologies that can be used to deliver adequate nutrition, especially micronutrients, to residents in low-income countries, and thereby help to promote human health and economic development. At the Food Systems Institute, I am a core member and I provide expertise in the areas of food and nutrition security. In my laboratory group, we have several areas associated with hunger, especially hidden hunger, or the lack of micronutrients in the diet and their effects and consequences to health. In one area, our team is developing a low-cost colorimetric sensor for the determination of iron and zinc in fortified flours. In another area, my team is modifying the protein structure with the intention that can be more amenable for the chelation of iron and zinc, and also for the formation of nanostructures that better deliver vitamins in the food supply. In another area, we work with emergency relief foods with the intention to add bioactives that can better address parasitic infection, so the product now can provide nutrition and antiparasitic bioactives, so making the food more effective. Finally, I lead the nutrition team of the Soybean Innovation Lab. In that effort, we want to add soy flour and other soy ingredients to enhance the nutrient density of foods in sub-Saharan Africa. Today, I will tell you about our low-cost colorimetric sensor for iron and zinc. Many years ago, we visited many countries around South Asia and Latin America and sub-Saharan Africa, and we found something that they all have in common. They have the inability to measure the micronutrients that by law should be added into flours, such as corn or wheat flour. We learned that the main reason for this to happen is the lack of laboratory supplies, trained personnel, and infrastructure, as it's very expensive to measure micronutrients and do analysis in countries. As a reaction to this, we developed a low-cost paper-based sensor, which we embedded chemicals into it. So when the addition of a sample that has been mixed of a flour with diluted acid, it can change color immediately. And then we can measure that color using a camera from, for example, a cell phone. This technology is a game-changing technology, as enabled two big players in this business of fortification of flours in low-income settings. On one hand, it provides a tool to the food industry to be able to provide information about what they're doing with their flours, especially iron and zinc. On the other hand, allows the government to have a tool so they can measure these flours as they are fortified in different countries. So in that way, we can be certain that the food supply is regulated and that the food won't harm you. These micronutrient sensors are needed everywhere. And our team continues developing these sensors, now focused on the addition of zinc. As you can imagine, we have to validate this technology against gold standard measurements, such as atomic emission spectrometry. We have those tools at the University of Florida. We will continue doing this great work. For that, I hope you join us in our lab and help us fight hidden hunger in many countries. We have opportunities both for undergrad students and grad students. And I would like to invite you to join me to fight hidden hunger today. Thank you.